Hello everyone. So welcome to the video lecture series of Theory of Automata and Formal Languages. So here we are into unit number 4, that is push down automata, and we are into lecture number 3, which is an extended part right now. And here we will discuss two numericals. Okay, and in these two numericals we will see two different types of languages, and we have to construct a PDA. So basically, in these two examples, I will only explain to you the transition diagram. Why so? Because the transition diagram is the only one which will help you out to understand how the flow is going on. Okay, so once you are done with the transition diagram, if suppose it is not asked in your university question paper also, but my suggestion to you is that in your rough work you please draw the transition diagram, and with that you can easily write down the transition functions. Okay, so basically in this lecture we will see two types of languages. Earlier we have already seen language that is I think a to the power n or b to the power n, right? So where we understood the construction of PDA through transition diagram and also through transition function, right? So in this example, we will only check how to draw the transition diagram, and transition function already I have brought for you, and I won't take time on that. Okay, and then we will check it out a next language in the third example. Okay, and in this example, we will also see how to skip a particular transition. Okay, now let us start off with the example. So the example is given to you is that well, design a PDA for the language a to the power n, b to the power twice n, where n is greater than equals to 1. Okay. Now, as such, we cannot do infinite languages, and I cannot explain infinite languages. So I'm taking only a value, finite value of 3, n equals to 3. So the string will be of this pattern: a, triple A, and 6 times b as b to the power twice n. And then in the input tape, I have taken the epsilon in order to finish it off. Okay. So here, if you want to start off with your own logic, how you are going to apply for this, you can pause the video and you can think of it. Because as you can see, for 1A, there are 2 B's. If you put the logic like this, correct? For the second A, the third and fourth. For the third A, then fifth and sixth B. Like this, it will carry on until it reaches the twice n, right? And nth value. So what I can do is that for 1A, as there are 2 B's, so after this is for sure that all the 3 A's I have to push into the stack, because in order to memorize this pattern, right? And once I start off with the B's, for the first B I will skip. That means I will only read the B and I will skip the pop operation for A. And on the second B, I will pop the first A. Similarly, for the third B, I will only read the B. That means I will skip the transition. That means skipping the pop operation. And on the fourth B, I will pop the A, second A. And similarly, for the fifth B, I will only read the element and I will skip the transition. And for the sixth B, I will pop the third A. So this is my logic behind this. So how to draw the transition diagram? This is my concern, right? So let me take to the diagram. So initially the stack is empty, correct? So initial transition is always the same and the final transition is always the same for every transition diagram. Only you have to understand the middle part, correct? So let me take the initial state as Q naught. Okay. So initially what happens? Again, I'm reminding you, A, B tends to C, correct? What is A? A is nothing but the input element which you are reading. B is the top of the stack that is to be popped. And C is nothing but the element to be pushed, right? So what in the initial stage, epsilon is the input element, right? That means nothing to be read. And initially the top of the stack is nothing. That means what I have to do? Push Z0. So I have pushed the element Z0 over here. Then Q1 is the next state, correct? Now what I have to do, as I already know that the pattern is that a to the power n, b to the power twice n. That means after finishing all the a's, then b will start. So definitely for all the a's, I have to push into the stack, right? So what I can do, I can take a self loop, and I can write like this: on seeing a, what is the top of the stack? Z0. Okay, I am not writing top of the stack, I am writing epsilon. That means nothing to be popped, right? And what I have to push? A. So all the A's. So first A will be push, correct? And this is done. In the second A, again the same transition will be followed up, and the second A will also be push. And similarly, the third A, it will also be push. So in the same self loop, these three pushing operation will be done easily, correct? So in some books also, in some video lectures also, you can check it out. In some faculties also used to say, used to write like this: a comma epsilon, and you can write like this: a. In this also they used to write. Okay, so it's not a big deal. Or for this particular transition, as you can see, A is the input element that is to be read, and top of the element I haven't mentioned, but I have mentioned is empty. This means that nothing to be popped. In this place, you can also write like this: A Z0. So this means that I have nothing to be popped. So I'm not popping out Z0. That's why I'm writing epsilon. So this way also you can write it down. So it depends on you, right? Okay. So leave it. So now the all pushing operation is done. Now what I have to do, I have to now read the B, this next element. So as I've already told you earlier, that on seeing the first element B, I will only skip the operation, and on seeing the second B, I will pop the top of the stack. Correct? So what I have to do, on seeing B. So this is the skipping operation. Please keep in mind. On seeing B, what is the top of the element? A is the top of the element. And again, I am pushing A. So is there any A? No. So that means this popping operation of this A is being skipped. I have only read this element B. Clear? So that means what is the top of the stack? That if you have to push it, then this will be a skipping operation, and this element will be read simply. Clear? Now Q1, after Q1 it will move to another state, say Q2. Now this B is read, I will move to this B. As I have told you, for this B, what I have to do, I have to pop the top of the stack, correct? So I will take one more state and let it be Q3. So on seeing B, what is the top of the stack? A. What is to be done? Epsilon. This means what? The top of the stack will be moved, and it will move to its original position. Clear? Now tell me, again I have to do what? The same process, right? Again for this B I have to skip, and again for this B I have to pop. Again for this B I have to skip, and again for this B I have to pop the top of the stack, right? So what I have to do, besides taking one more state, I will directly backtrack. That means on seeing B, what is the top of the element now? A, and I will do the skipping process. That means only I will read B. Again you can check it out. This B is done. Again for this B, top of the stack is A, so this will be removed and it will move back to its original position. Correct? This is done. Again for this B, again this B will be read. Top of the stack is A, and this will be skipped. Correct? So this is also done, and finally I am reached with B. So on seeing B, what is the top of the stack? A, and what is the operation to be done? Pop. So this will also move out and it will move back to its original position. Done. So all reading, all inserting, all deletion, everything is done, and I have reached the final empty position. That means from this state I can take to the final state, right? I can take to the final state and let it be QF. And what will be this transition? On seeing epsilon, what is the top of the stack? Z0 is the top of the stack, and what I have to do? Epsilon. Clear? So it might not be visible. I will write nicely. On seeing epsilon, what is the top of the stack? Z0, and what is to be done? You have to do the pop operation. So Z0 will also be removed. Again, the empty stack will be empty. So this is the general overflow or flow diagram, or you can say transition diagram of this particular language. Clear? So basic concept is to understand the language and how to operate on it. So as I have told you, for the first for the first B, I will only simply read, and for the second B, I will pop the first A. Similarly, and so and so. So skipping operation, already I have told you that only if I am reading this B and top of the stack is A, then I will again do the pop the pop push operation A. Since A is not there, so that means this is already is a skipped one. That means only B is read. Correct. So this is the transition diagram. Now I have already drawn mentioned here the transition function for you. Okay, so you can pause the video and you can note it down, but I have already explained to you in the earlier video, so I'm not extending this particular part. The most important is to understand the transition diagram, then it will be very much clear to you. Clear? So you can also check it out. This is the as I've already told you, this is the part, the acceptance by empty stack, and until it reaches the final is acceptance by final stack. Clear? That I've already told you earlier. So you can check it out, the process, the same one, epsilon 3 times A, then 6 times B, and then final epsilon. Clear? So this is one example where we have understood how to construct a PDA from the language A to the power n, B to the power twice n. So in the next extended video lecture, I will do one more language. I have earlier only I am mentioning it. The language is WCW to the power R. That means whatever string you are taking, followed by a C, and then reverse of that particular string. So I will look into that particular context-free language, and we will check it out how to construct a PDA for that. Okay. So thank you for watching this video. Any doubt, please, I again request you comment down below and we will look into that matter. Okay. Thank you. Thanks a lot.